Hey, what's up, guys? Just down here in the shop and thought I'd make a sort of a conclusion wrap-up video for the China Ballnut Rebuild series. Yeah, pretty sick. So yeah, trying to think since the last video had the table on there, and yeah, so we'll talk about the Ballnut. Maybe we'll do like a Backlash thing, and I also added some way covers. There's some covers for the covers, as well as a couple of other things. So let's dive in, huh? So we've come in for a close-up, got a 1-2-3 block on the table and a DTI and a tool holder in the spindle, and we'll see what it is. I've already done this a couple times, so I know what to expect, but yeah, I think I can compare the Y, which does not have linear rails. It's got the factory dovetails, just dolled up a little bit, and the X, of course, has linear rails, and of course, the nut that I just rebuilt and spent a bunch of time going through, it's far better than the Y. But I think where you notice the most difference is that the linear rails just have such, they just move so easily, so you don't have that sort of sticky lost motion due to less than perfect dovetails. So I feel that, I mean, the linear rails, they just work better than cheap Chinese dovetails, and possibly just due to the fact that they fit proper and they're nice and tight. I'm sure if you had really nice dovetails, then probably wouldn't be considering doing something like that. But let's jump into this here. Enough rambling. So I just have the I'm using the pendant to jog, and we'll come up. We'll zero it. Maybe something like that. It's pretty good. And we'll zero the x-axis. It's been zeroed. Go back to steps, and we'll come back and we'll watch the DRO versus the DTI. There's one thou. So there's 10 thou, and then we'll come back to 0. Yeah, so I'm pretty happy. That's a half thou indicator. You know, there's probably, you know, a couple tenths of backlash as it is now. So yeah, I think it's an improvement, and I wouldn't be surprised if it opens up through use, but I was never really unhappy with the backlash. It was all of the other problems with the screw being bent and the ends not being concentric, so yeah, I'm really happy, and yeah, I think we'll chug on until we have to revisit, if we have to. Fingers crossed. Knock on cast iron. All right, let's talk about the covers, the way covers. So yeah, I have the cool weight covers that fit on there, and they work great. And I don't know, I just found myself stuff sort of piling up in there, and yeah, so I figured why not put a cover on a cover, and this is what I come up with. It's 32nd, Ballnut and sheet rubber from McMaster, and I believe it's 32nd inch, just aluminum, some flat bar stuff, and then some sort of Z angle flashing looking things. So we'll dive in and check it out. Pick you up off the tripod here. Whoa. I'm having technical difficulties here. There we are. So after some head scratching and finger twiddling, this is what I came up with. It mounts to what the bellows actually mount to. I like the 32nd rubber because it's super flexible and has no really restricted movement, so it really folds nicely compared to even 16th. Come over here. There's a better side shot. Sort of sandwiched in between there. Hopefully, chips and stuff will sort of just sheet off of there, and it's easy to sort of hose out behind here because it lifts up. I originally thought of, I might want to put like something to hold it against there, but I think this will be easier for cleaning, so that's what I went with on that. Get a little better shot back here. I'm gonna be upside down here in a second. Doesn't really show you much. This is where it connects to the back of the saddle. Same kind of thing that's up top, sandwiched in between some little sheets here. And I also added a flashing. Probably have to reposition to show that. Super slow pan, man. And we'll bring the Z down so you can see sort of how it stacks. So there's that. Here's a better view of the back, seeing where the rubber meets the saddle. And this was the other thing. This was this Z-shaped stock got from McMaster, and that was to address the back here is where the cars for the X-axis sit. One right here, and then one over there, and shit was just going through this little gap in between the saddle and the cars, and in between the two cars was all packed full of aluminum chips. So figured I'd put a little something over that, and I installed that after I had already installed the table, so I had to get a little creative with how I got those little 440 screws tapped into there. This was my little drilling jig that I whipped up to get those holes in the back of the table. So this was I used this to use as a drill guide, and then I drilled the hole out for a clearance hole for the taps, and then I could use it to sort of guide the tap in. It sat right on there, and then I used a T-nut to bolt it on and just drilled, straight in that way, and that lined everything up. So it was sort of fun to figure that out, and I scribed a line on the bottom and to get the lines lined up for the holes. And the last bit of rubber activity was right here on the front of the table. And if you're familiar with these little mills, they come with, across the front right here, there's like a rule or a scale, a little tin scale that's held on with those little screw drives or screw drive rivets, I think they're called, and maybe some adhesive. But this table sort of gutter goes on the front, and the gap created where that rubber is now, like chips and stuff would get all packed in there and I couldn't get them out. So I cut some rubber and glued it on there with some adhesive. It's like E something 6000, just like rubbery kind of adhesive. And the gasket's just a little proud of the face of the table, so I'm hoping that it'll compress just a little bit and sort of seal it up nice, so I don't have to be bothered by that anymore. Alright, thanks for watching. Thanks to all the new subscribers. I appreciate it. And we'll catch you in the next one. Take care. Thanks.